Okay, here's a fun problem playing around with the sum and difference identities. We have that the sine of A is equal to 0.158 and the cosine of B is 0.783. And we also are given that angles A and B both terminate in the first quadrant. And we're asked to find the cosine of A plus B and the sine of B minus A. So we're going to work with those, work with the identities, sum and difference identity. And whoops, let me start with the cosine here. And so we know that the cosine of A plus B, according to the identity, is cosine of A times the cosine of B. So if the cosine, it was the same two functions, and then subtract sine of A, sine B. And I've got some of the values that I can plug in. I know that the cosine of A is 0.158, so I can plug that number in here. Cosine of B is 0.8 or 0.783, so I can put that number in there. But I don't know what the cosine of A is, and I don't know what the sine of B is. Oops, I forgot a parentheses there. So I can't quite finish off that formula until I know those. But we can get those if we think back to maybe the Pythagorean identity. We know that, sine squared theta plus cosine squared theta is equal to 1, and that's true for all angles that you work off. So in particular, I know that the sine squared of A plus cosine squared A is equal to 1, and I'm told that the sine of A is 0.158, so 0.158 squared plus cosine squared of A, cosine of A quantity squared is equal to 1. And so that the cosine squared A would equal 1 minus 0.158 squared. And so I can take the square root there to get what the cosine of A is. And that would be the square root of 1 minus 0.158 squared. And we are in the first quadrant there, and in the first quadrant, we know both sine and cosine are positive, so I don't need to worry about the plus minus involved with the square root. It could be a positive number or a negative number, but since we're in the first quadrant, I know it's the first one. So if I crunch those into my calculator here, if I took at the square root of, kind of doing this off camera, 1 minus 0.158 squared gives me 0.97-ish, and then if I take the square root of that, I get that the cosine of A here is giving me a value of 0.98743. Sorts of things. The question that we're looking with, the directions in our thing, in WAMAP are asking to round to 3 decimal places. I want to go a little bit farther than that when I'm doing my calculations, just to avoid any round over errors. Okay, and so I know that in this spot here, I'm going to put the 0.9874 in there for cosine of A, but I also need the sine of B, but I can do the same kind of trick. I know that the sine squared of B plus cosine squared cosine of B quantity squared is equal to 1, and the cosine of B is 0.783. So I know that sine squared B plus 0.783 squared equals 1, or sine squared B is equal to 1 minus 0.783 squared. And then if I take the square root to get the sine by itself, again, because B is in the first quadrant, I don't have to worry about the plus minus. And I come up with a value of, calculator tells me here, whoops, 0.62 202 for the sine of B. So I'm going to plug that into my sine of B spot, 0.62. 2202. So the cosine of A plus B here is going to be 0.9874 multiplied by 0.783 minus 0.158 multiplied by 0.622202. And we can just crunch the numbers on that. Although I'm having a feeling that I might have, no, maybe that's right. I think the cosine of A value, let me double check my calculation on the cosine of A. 0.158 squared, and then take the square root. Okay, yeah, 0.98743 is right. So I want to take that 0.98743, multiply 0.783, and then subtract 0.158 times 0.62202, and to 4 decimal places, I'm getting a value of 0.674849 if I round to 4 decimal points. 0.6748 for cosine A plus cosine B. And then for the second part, they wanted the sine of B minus A. Get my eraser back out here. Sine of B minus A, and the identity for the difference of angles is that sine B cosine of A minus sine A cosine of B. So my angle listed first here comes first here with the sine. I need the sine of the B times cosine A minus sine A cosine B. And with the sign matches SIGN. Positive, negative sign matches that if it's subtraction in here, I need subtraction on this side. With cosine, it was the opposite. When I've got a sum of angles up here, I wanted to use a subtraction in there. But with cosine, it's the same one. And I already actually have all these values now, so I just need to plug them in. The sine of B we found that was one that was given to us. Oh no, sine of B, did we calculate that? We calculate that. That's the 0.62202. Cosine of A, we calculated that one as well, 0.98743. Sine of A was given to us, the 0.158. And cosine of B is 0.783. So then it's just a matter of doing that arithmetic to come up with the answer. 62202 times 0.98743, subtract 0.158 times 0.783, and my calculator is giving me a value here of 0.4905, rounding to 4 decimal places, 0.4905 there for those values. So just we got to use a couple of identities there. We have to use the sum and difference identities. We get to use those in there, and then do the trig identities, the Pythagorean identity, to find the missing values. I've got cosine of B, so I can find from that, I can find sine of B, and I know the sine of A, and from that I can find cosine of A using the Pythagorean identities in there.